Okay, in our notebooks, we are starting today on page 48. We are talking about finding and classifying roots. So in some ways, it's going to be similar to what we did in solving polynomial equations. So it's going to be similar, but easier. What is similar is that you need to know how many roots or solutions a polynomial has, but you don't have to go through and solve them out like this to find those roots. So today we're finding how many roots a polynomial has. So similar to this, just not quite as challenging. So page 48, let's fill in our blanks. The solutions to a polynomial equation tell us where the graph of the function touches or crosses the x-axis. So in our last lesson, let me verify this. I told you, so I'm going to unfreeze. In our last lesson, before we even started solving polynomial equations, I told you guys that the solutions are also called zeros or roots of the function. So now we have a heading that says finding the zeros or the roots. And now we're going to think about them as where they touch or cross on the x-axis if you graph them. So we know these as x-intercepts. You guys know what these are. You know them as x-intercepts, but they are also called solutions, roots, zeros. Those all mean the same thing. X-intercept is the same thing as a solution to a polynomial, the roots of the polynomial, or the zeros of the polynomial. So on all of these down here, it wants us to find the roots and highlight multiplicities. So we've been exposed to multiplicities before. These are roots that occur more than once. I'll give you an example of that in just a second. So multiplicities are roots that occur more than once. So I had to do some solutions in my notebook because I wanted the room to work out the problem. And this is one where we solved this polynomial equation right here. And 3 of our solutions were 0. That is a multiplicity. All that means is that I had more than one 0 as a solution. So this would be considered multiplicity 3. So we want to be on the lookout for those. Okay, so for our first one, and actually on all of the problems, the first thing that we're going to do is decide how many roots that it has. And this one has 3. Does anybody remember how I know that? The exponent. The biggest exponent tells you how many roots you're going to end up having. It is important that you know that before you start the problem. So this one is going to have 3 roots. Now, based off of what we did last time, we would have to factor out this polynomial and then solve it. We're not going to do that. We're going to skip that for now. So we know that this is going to have 3 roots. Over here, we can fill this out. If the function is not written in factored form, you need to factor it or graph it to find the roots. So if it's not in factored form, you have to factor it or graph it. So this one is not in factored form. This is standard form, which means we got to factor or we got to graph. But luckily, the next two are in factored form. So number 2 is in factored form, meaning it's written as different polynomials being multiplied together. This is not factored, this is factored. Are you hanging in? Okay, how many x's are in this problem? 3. So there are 3 roots to this polynomial. There are 3 roots to this polynomial. Now, notice how these are different. If your function is in standard form, the biggest exponent tells you the roots. But if it's in factored form, you have to count up how many x's you have in the expression. This one is easier for us to find the roots. So we would have x plus 7 equals 0, 2x minus 1 equals 0, and 3x plus 2 equals 0. And to find the zeros or the roots, we would just solve these. And I'm going through these ones because these ones are easier ones to solve. So for this very first one, to get rid of that plus 7, what do? Minus the 7. So your first root is x is negative 7. This one's a little bit more involved because we have to get rid of the 1 and then the 2. So we add the 1 over first. You get 2x equals 1. And then you divide the 2. So you get x is 0.5 or 1/2, whatever you prefer. Now I am going through this faster because I am not expecting you to have to solve a bunch of equations on your quiz. I just want you to see where these roots are coming from. So let's do the last one. We subtract 2 first. You get 3x equals negative 2. Then you divide by 3. And you get x is negative 2/3. So we knew before we solved these out that we were going to have 3 roots. And now we know the exact value of the roots. Well, let's double check this in Desmos. So if I go to my internet, and I'm going to type in the factors. I'm not going to type in m of x equals. I'm just going to type in these 3 parentheses. So I type in x plus 7. That's not a 7. Is it 2x minus 1? Is it a minus 1? Yes. Thank you. And then 3x plus 2? Yes. Okay. What I need for you guys to notice is that this graph crosses through at -7, -2/3, and 0.5. That's what we're finding. We're finding where the graph crosses at 0. If I zoom out, you can get a little bit better picture of what this graph looks like, but not a great one. He's like a crazy roller coaster. So you guys go to Desmos and plug in this one to find out what the roots are. You should have 3 by the time you're done. Because remember, this has 3 roots. So plug in just 3x cubed, plug in just 3x cubed, minus 6x squared minus 9x. Don't plug in the f of x, just plug this part in. Do you need a Chromebook? You can borrow one of mine. In the cart. Are you doing this? Should I come? I'll come. I'm coming to walk through. Here I come. Just bring all my notebooks with me. Write down your solutions if you found them. Just like on my screen, you should have 3x equals. So you can click on them where they cross through the x-axis. It'll let you click on it and it'll tell you the value. Okay, I'm walking around and seeing that lots of you guys don't have this. On number 1, write down what I have. X equals, and write your 3 zeros in there. Go, move your pencil. Don't make me roast you publicly, because I will. Be like, Carly, write your zeros down, ma'am. Just need the first number. So just the x value. You know what I'm saying?
So did I do that right?
Yeah, your 0. Yeah.
Oh, I was like,
yeah.
You want me to do it with 0?
No, I was just sweating you because I know you would cry. Guys are worrying me. Why? Because like five of you don't have this done, and all you gotta do is plug it into Desmos. Do you know what I'm saying? Okay, so in Desmos, I'm plugging in 3x cubed minus 6x squared minus 9x. And then I have to hit the home button because you can't see where it crosses. All you need to do is identify where it passes through the x-axis. You write down the first number only. So we would write down x is -1, x is 0, and x is 3. So back here, I should have a, what was it, -1? 0, 3. So if I went through and factored this, I would end up getting solutions that were -1, 0, 3, which means that I would have had the factors x, x plus 1, x minus 3. That's what this top thing factors out to. You don't need to do that. I'm just showing you that what we did here is what Desmos is doing for you when you graph it. We don't have any multiplicities yet, meaning we don't have any duplicate solutions. All of these are different. So number 3 is the first one where we have multiplicities. This is the first one where we have multiplicities. Now, luckily, our expression, our polynomial, is factored. So we're going to break that out over here next to this fancy bracket. Should we decide our number of roots first, though? Yeah. See if you guys can figure out how many roots this is. Really try. You don't got to write it down, but really try to figure it out. Okay, I heard one of you say it. 7. Okay, so you have 2 x's here, 1 x here, and another 4 x's here. Because what this expands to is the following: x plus 5, x plus 5, x minus 1, and then x minus 6 4 times.
Whoa.
So compare that to the polynomial and see if it makes sense to you. We have x plus 5 squared, so we have 2 of those, x minus 1, and then x minus 6 to the 4th, so we have 4 of those.
Oh.
Do you see what happened there? So now, if we solve these, our solutions would be -5. How many of those do we have? 2. So underneath that, I'm going to write M3. That means multiplicity. I didn't mean 3. M2. That means multiplicity 2. Meaning we have 2 -5s. My next solution would be x is 1. Do we have a multiplicity there? Nope. What's my last solution? X equals 6. What's your multiplicity? 4. So we just did these in our heads. What would be the solution to x plus 5? A -5. What would be the solution to x minus 1? A +1. Are you guys hanging in? You're sure? Okay, so the first question in your quiz is like 4, 5, 6, 7. So you guys go through and decide what the number of roots is. Sorry. And if there are multiplicities. So for instance, x plus 2 is a multiplicity. So underneath that, write multiplicity 5. Just right underneath it. Okay, you go through those 4 problems and decide the roots. I'm going to graph this last problem and then come check on you. Okay, I'll come walk through.
Oh, these right. Why what? Are they right? Oh, I didn't do them yet.
We'll find out. Okay, number 4 has 1, 2, 3, 4, 9 roots. But only the one that I labeled is a multiplicity. This x squared minus 49 is not a multiplicity because he factors to x plus 7, x minus 7. So those are 2 different solutions that would come from x squared minus 49. Also notice that whenever you have a multiplicity, the exponent is on the outside of the parentheses. So up here with multiplicity 2, he was outside of the parenthesis, and multiplicity 4, he was outside of the parenthesis. Okay, number 5 is 4 with a multiplicity 3 on your x plus 2. So you would have your solutions to this would be 1/3, -2, -2, -2. Number 6, no multiplicities, 5 roots. What'd you get? Okay. Number 7 is 2 roots. No multiplicities. How'd you guys do? Did you do okay? Okay. Now the next page is where things get slightly complicated. So we turn thy page. Classifying roots. So now that we can tell how many roots a polynomial has, we have to decide, are they real, imaginary, or complex? So you start, and if you have highlighters, highlight this. You start at the complex roots. You start here. In all of the questions that we answer below, the first thing we're going to decide is how many complex roots it has, because your complex roots is just the same thing as the total number of roots. So that's what we just checked. That's what we just checked on those last 4 problems. So right here, this has 9 complex roots, 4 complex roots, 5 complex roots, 2 complex roots. The complex roots is just the total number of roots. The real roots is the next easiest thing to find. So start at the complex. Then the next thing that you want to do is check the real roots, because these are your x-intercepts. You can see real roots. So I'm going to zoom out just a little bit. Draw a picture. So these guys that I have drawn here are real roots. They are touching or crossing that x-axis. So real roots, you can see them. You can see real roots. Your imaginary roots have an I, which means you can't see them. You cannot see them on a graph. So the last thing that you find is your imaginary roots. And then this carries over from the last page. If the function is not written in factored form, you need to factor it or graph it. So for number 1, this box down here is what we are actually determining. We are figuring out how many are real how many are non-real, how many are complex. So remember, we start at the number of complex, so you just count up the x's. How many x's do you have? 3. Okay, now we could go through and solve these. You don't have to rewrite them like this if you don't want to. I know that a lot of you can just solve these in your head. So our first root is positive 4i. What's our second root? Negative 4i. You should be getting that because you're subtracting this 4i to the other side. Here we added it. Then our last one is minus the 3 divide by 2. So you can just write negative 3 over 2 if you want. So one of these was real, 2 of them were non-real, for a total of 3 roots. So you should be able to add these 2 things and get the number that you started with. Is this making a little bit of sense?
Yeah.
Are you sure? Okay. So on number 2, what is our total number of roots going to be? 4. You have 2 here, 2 here. Okay, well now we're supposed to factor these, but the good news is these are special, meaning you root the first term and you root the last term. So x plus x minus, what's the root of 121? I'm not going to tell you. The square root of 121. What is it? 11. So let me highlight that for those of you that might be lost. This x squared minus 121, factors to x plus 11, x minus 11. Okay, well the second one does the same thing, but he's slightly different. What's his slight difference? It's imaginary. How does Cheyenne know that this turns into plus 5i and minus 5i? Because it's a positive in between, not a negative. So this goes back to factoring. So our solutions are negative 11, 11, negative 5i, 5i. How many are real? How many are imaginary? Notice that they add to the total number of roots. That's why you always start with the complex. So I am going through this very quickly, and here's why. Because what I'm assuming is most of you guys are just going to plug it into Desmos. You need to be aware of one thing though. So if I go back to this same problem and I plug into Desmos x squared minus 121 x squared plus 25. Zoom out. What I want you to notice is you only see the 2 real roots. You only see negative 11 and 11, which means that you would need to know to fill into the imaginary one that there are 2 that you can't see. Does this make a little bit of sense, what I'm saying? So you started, I'm going to say that again. We started this problem by knowing we were going to have a total of 4 roots. True story? Yes? So I go to Desmos and I plug it in. On the other screen you can see it, and I only see 2 roots. What that means is 2 of your roots are real, because remember, these are your x-intercepts, you can see them, and 2 of your roots have to be imaginary, and you can't see them. That's exactly what you're getting up here. 2 real roots, these are the ones that we can see. These ones you cannot see on Desmos. So you need to know that there's 4 total roots, and if you graph it and only see 2, that means the other ones are imaginary. Does that help a little bit? Okay, because numbers 3 and 4 are ones where you would just graph it. So what this little box is for is use Desmos. If it's not factored, my recommendation to you would be to plug it in Desmos after you decide the number of roots. So on number 3, how many roots are you looking for? 2. And on number 4, you're looking for 3. So plug those into Desmos, plug in number 3 first, and then plug in number 4. Go. Really try it. All you have to do is plug stuff into Desmos. At the junior high, I used to tell the kids, a monkey could do that. No, I went to Westlake, but I taught at Matheson. I almost burned my whole finger off in woodshop class with the hot glue gun. Because ain't nobody told me those things are hot AF. It was horrible, Carly. Horrible. It was sad. It's the only distinct memory I have. And that we had a really good ballroom team. It was awesome. Are you yelling at me? What?
I'm so confused.
No, you're not.
Yes, I am.
Okay, ma'am.
Look.
Yeah. Yeah. How many of them can you see? None is what number?
0.
0.
Oh, okay.
So then how many have to be imaginary, ma'am? Good heavens to Betsy. Listen. If you can't see them, that means they're imaginary.
Silly shy, come on. Just kidding. Were you confused too? Yeah, I was okay, then I don't feel like that.
Plug them both in. Do both. You have like 7 questions like this on your quiz. Like your quiz is almost all questions like this.
Wait. Hold on, I didn't finish. Oh, because you can't see 3 of them. There's 3 imaginary. Yeah, so the real ones would be 0. Yeah.
Okay.
Yes.
We're gonna check in. The first one is x squared plus 2x plus 5. Yes. And then you're all annoyed because it doesn't pass through anywhere. However, we know that we have a total of 2 roots. We just can't see any of them. So that means none of them are real. Both of them have to be imaginary. And keep in mind that they add to the final number. The top 2 equal the total at the bottom of the table. 0 plus 2 is 2. Are you okay with that one?
Yep.
Okay, so then the next one is cubed plus 10x squared
Yes.
plus... Okay, so now I zoom out on this one and I'm like, well, what in the hell? So it looks like the only place that it passes is at 0, 0. So this is 1 real root. And if I'm supposed to have a total of 3, how many of them must be imaginary? Dose. Do you see what's happening here? Are you sure? I feel like we should do a couple and I should pick sticks. Hugo. Oh, you're just tired. Okay. I think that I'll stop here and just be cruising around while you guys work. And if you're lost, you'll just stop me or I'll just creep on you and help you. Do you know what I'm saying? Okay, get going. Oh wait, I gotta publish it.
No, we did that one already, you know. Oh.